Hi, in this tutorial, we're going to look at building a mouse theremin in SuperCollider. All right, so here I have SuperCollider open, and I'm going to start with a basic synth def. So I can give you an outline. Basically, the sound making units in SuperCollider are contained with, for the most part, in these things called synth defs. So if you can think of it as a template or a map, something which you sort of build a definition, it's a synth definition, and then later on you use. Okay, so I'll show you the basic syntax of the synth def. It's SNTH, a capital DEF. Now, remember, SuperCollider is cap sensitive, so do capitalize all the ones I have capitalized. And we're just going to put two parentheses like that. So these parentheses or brackets really are just an enclosure. They just say that everything contained in these two brackets will be in the synth def. Okay, and the first thing that the synth def looks for is a name. So we're going to call this MT maybe for mouse theremin. Now you notice as soon as I put a comma there, it gives you these hints, and the hints basically are telling you all the things that the synth def looks for. Okay, but we're going to focus mainly on this thing called a UGen graph function, which don't worry about that sort of jargon. We're going to put some curly brackets in there, and that's going to be the function. Everything within these brackets really is going to be these curly ones. It's going to be the sound making part. Okay, that's our name, the sound making part, and that's pretty much it. And then we're just going to do a dot add at the very end there. Okay, so that just means we're adding it to our server. You don't worry about the sort of server client relationship right now. It just, this adds our synth def and it's ready to use. Okay, so now if we're to send this thing, so remember in SuperCollider, you evaluate by either highlighting, or you can evaluate single lines by just having the blinking cursor on that line. And then if I just hit command and return, that's going to evaluate. So you see down here in my post window, it says a synth def. So basically I've added to the server a definition titled empty. Now this little guy here, this / is, or backward slash, I guess, is really a way of saying that this becomes a symbol. It's just a way of telling SuperCollider that you're using this as a word, as a symbol. Okay, so that's empty, and it's nothing right now. It's just an empty function. So that's what it does. If we were to play this, nothing would happen. Okay, but that's their basic format right there. So I'm just going to do this in steps. I'm just going to sort of be redundant and repeat stuff. So we're going to take that, what we've done, that work we've done already, just leave that there just so you can see that that's actually what we're filling in. And I'm just going to add a couple lines there, because really what I want to do is I want to now everything that's going to go in these curly brackets is going to be my sound making bit. Okay, and so I think the first thing we need to think about is this UGen called out. So when I say UGen, SuperCollider makes sounds based on these things called unit generators, and basically they're little sound-making doodads that have been, hard coded into the SuperCollider server, and they're things like an oscillator, which will create tones, or things like envelopes, which will make envelopes or filters, and they're generally referred to UGens. But UGens can be many different things, and they mostly have to do with making sound. So the first UGen we're going to look at is this one called out, capital O-U-T. And SuperCollider can have control rate or audio rate UGens. So you do have to specify. This is going to be an audio rate one, because out, and again, these brackets there that just show you what is contained in out. So out is containing these things, and it'll be a number of arguments. And out is basically how you get your sound out to the speakers. So out.ar. And then we're going to have a channel number. That's the first thing it looks for. Or they say bus here. And that just means what speaker you're going out of your sound card. Or you can also send it to a private bus. But 0 generally will be your left channel, your left speaker. Or if you have a mono system, your only channel. Okay. And then your channels array, which we won't worry about right now. But basically, it's what you're going to send out the left speaker, the 0 speaker. So we're just going to leave that blank for now. Okay. And what we want to do is we're just going to create a tone. So if we make so within synth defs, you can have variables and arguments, but we'll just start with variables, vars, variables. And we're going to make a variable called synth. Okay. and then we're going to define that variable. So basically, vars, or variables, are used within the synth-def just to make things a little bit more clear and easier. And then we'll encounter arguments later. Okay, so if I do var synth, and then I define synth, synth equals, and I'm going to make an oscillator, sine tone. So I'm going to use this ugen called sine, S-I-N, capital O-S-C, and then again it's audio rate because it's going to make sound, .ar. And if I just put the two little brackets there, that just means it's going to make the sine oscillator and just use all the sort of default settings, okay? You notice if I put a comma in there, it shows you all these settings here that I can use. But in fact, I'm just going to use the default settings there, sine os, AR, okay? And then I'm going to pop out the out bus. I'm going to pop the synth out. All right. So if we just to get started, if we just do that, if I'm setting my synth, which is now equal to the sine oscillator, and now it's going out to my left speaker, if I just evaluate that, so highlight all that, command return, now it's ready to go, but you notice there's no sound playing. Well, for a number of reasons, but the main one is that, remember, it's just a definition. So this synth def is just a way to define a certain sound making process, but we haven't called it. We haven't said play for me, right? We just have made this definition like a template. Okay, and in order to get it to actually play, we have to make a synth. And so this is good in a lot of ways. One interesting thing is that you can make many different synths based on the same definition. So if I wanted to make 10 of these, I can make 10 of these based on this one empty definition. Okay. In this case, I'm just going to use a variable a equals, and I'm going to go synth. Okay, and then I'm going to tell it the name. It's going to be the synth name MT. All right. So if I do that, and then the other reason why we didn't have any sound is because I need to boot my server. So we're going to put a line of code in here, go s.boot. We can do that, or you can use Command B. So I'm going to boot my server there, and then I'm going to send my synth def again, and then I'm going to play it, and there you go. We have our sine tone that it plays. Okay. Now, if you want, once it's playing, the synth is now A. So A is equal to the synth, but whenever I want to do anything to the synth, I do it to A. So if I want to kill this, I can just do A.free, and that will kill that A synth. If I want to kill all sound, it's command and period, and that'll kill all the sound. Okay, so now that's kind of interesting. At least we got SuperCollider to make some sound, but in fact, what we want to do is we want to be able to change the frequency. That might be kind of interesting. So let me introduce you to this concept of arguments. And again, I'm just going to kind of replace this and recurse this every time, just do a new one every time we learn sort of a new concept. So this is the idea of arguments, A-R-G, args, okay? And they're similar to variables in that they're names that you assign things to. But arguments are accessible from outside, at this process here, all right? So you can change, for example, something like the frequency. So let's do that. FREQ, we'll make an argument called freak. And instead of just having this blank in here, or the default setting, which is 440, the frequency, that's our first argument, we're going to make the frequency freak. So the argument basically passes in a number of some sort, or some kind of variable, and that passes it to this synth here, okay? So let's set a default setting. We will say equals, say, 300. And that just means that when you start it, unless you specify a setting for the freak, it's just going to be 300. Okay, so let's give that a try. And each time I change the synth, I have to re-add it, and it'll replace the old one. So you see there, it's a lower frequency sine tone at 300. And then in this case now, remember again, the synth now is actually this thing called A, because A is the synth. If I evaluate just that A, it shows me it's a synth, MT at node 1000. So I can use the set command, and this is the power of the arguments. This is where the arguments come in. If I do A.set, I can change arguments while it's playing or on the fly. So I'm going to change the one called freak. Okay, and then the syntax is simply the name of the argument, comma, and then the value that you want to change it to. So if I want to make it really high, say 700, I just do that. 700. And I can do that as much as I want. Say 50, really low. Okay. All right. And then I can free it. Okay, so that's good, except really what we want to do is we want to control the frequency with our mouse. Okay, so I kind of lied. I'm actually not going to use, I just wanted to demonstrate in an easy way what the arguments do. But in fact, I'm just going to have a mouse in here. So I'm going to get rid of this guy here. But we do have to put something there, but I'll show you what we put there later. And instead of freak here, we're going to have a mouse function. So if you use this function called mouse x, that'll use the x-axis for frequency. And this is a control rate because it's giving you control information. It's not, we're not actually sounding the mouse. It's just telling you what frequency, .kr. Okay, and again, these two little brackets, oops, we're on ones. And that will, that has its own arguments. But these two belong to mouse. And then everything in these two there belong to the sine. Okay, so the mouse is now setting the sine thing. So we can set up two limits here. What it's looking for is a min val and a max val. That means min val will be all the way over here, and max val will be when the mouse is all the way over here. So for min val, let's set it to, say, 100 maybe. And then the max val, maybe we'll just set it to 1,000 for now. Okay, and let's give that a try. If you evaluate that. Oops, I made a mistake. Oh, yeah, see, it doesn't like an empty arg line. So I'm just going to comment that out. Two forward slashes like that comment for a single line, and that'll comment that out. And so let me reevaluate that. Synth def, that means we're good to go. And then we hit it. And now, see, depending on my mouse position, it will play somewhere between 100 and 1,000. That's quite nice already. So we're getting the means of a mouse theremin. Now, how are we going to use our args? Well, one thing we can actually assign to our args is this low and high range. You know, we don't want to be stuck from 100 to 1,000. We can change it on the fly. So why don't we say freak low? Actually, I'm going to get super fancy here and actually do something based on pitch, and then introduce it to frequency. So if we want to use Midi pitches, so Midi is this system for, I mean, I'm sure most of us have seen MIDI devices. They're keyboards or other devices that talk to your computer and using this. So MIDI is really a protocol. But one of the things it does is it gives numbers to pitches. So for example, 60, and it's a linear system. So for example, 60 is middle C. So the MIDI note 60 is in middle C. That means that 61 will be C sharp, and 62 will be D, et cetera, et cetera. So it's nice because it's linear, whereas frequency is it's exponential, or it's logarithmic, I should say. So simply meaning that 100 and 110 and 120 isn't exactly necessarily like half steps. By the time you get higher, it takes a lot more of them, maybe a few hundred or something to get one half tone. Okay, but we can use these MIDI notes to make sure that every single increment, every one increment is a half step. Okay, so like 60, 61, 62, or 80, 81. So let's go, let's use these MIDI numbers, okay, and we'll call them pitches, okay? So we'll make an argument called pitch low, and we'll have another argument called pitch high. Okay, and that'll be the two ranges, and then we'll do a little conversion trick that I'll show you. So pitch low, let's start maybe an octave below middle C, should we? Or 2 octaves below middle C? Well, let's do an octave below middle C. So what is that? Minus 12, so 50, 48. And pitch high maybe an octave above middle C, so 72. Something like that. Okay, and then we can just pop those into the mouse XR. So instead of 100 to 1,000, we're going to go from pitch low, to pitch high. All All right. So that just means in this case it's going to go from 48 to 72. Now the last thing we have to do now is if we just leave it like that, it's going to go from 48 hertz to 72 hertz, which is both of which are very, very low. It'll just be really, really low pitches. So we have to convert that back to hertz or cycles per second. Okay, and that's a bit technical, but I won't explain that necessarily right now. I'm sure a lot of you know what the difference between cycles per second and MIDI notes are, or if you don't, there's lots of stuff you can look that up, but I won't go into it right now, so we can just get through this code. So I'm going to use a little function, a little conversion function here. That means that this right now, the mouse is cranking out some number between 48 and 72, depending on its position, okay? And whatever number that happens to be, I'm going to convert that from MIDI to CPS, cycles per second, okay? So that's going to convert whatever MIDI note here, it's going to convert it to cycles per second. So somewhere between 48 and 72, MIDI CPS, okay? So then that'll give me the right frequency. So now, in fact, I'll be playing pitches somewhere between, 1 octave below middle C to 1 octave above middle C, all right? So that should work there. And then the nice thing is now that these are arguments, you can change those on the fly. So let me send that, and it works here, synth def, and I'll play it. That should be an octave below middle C to about an octave above middle C. And the nice thing now is we can set those limits. So let's say I want to really constrain, which is 1 octave. So let's go from middle C. So if I do pitch low, and then just make that 60. Oops, not 600. That'll be very, very high. And then go pitch high. And then we'll make that 72. We'll just constrain the whole range to 1 octave. So this will be, and then those will be, so 1 octave range there. Very good rendition. Okay, so see how that works. So arguments you can set on the fly. Here you have this mouse going from pitch low to pitch high, and you just have these defaults set to 48 and 72. And we're using linear MIDI notes, so we know exactly where we are. You can download and Google charts and stuff that'll tell you what note is what, so you can be very precise about what pitches you hit. Okay, so that's pretty good. Already we have our mouse theorem mostly there. Now, let's make another version here. And we have all these versions. We'll just continue scrolling through. We'll make another version, and now we're going to produce by a few magic steps. We're going to allow our mouse button now to control when we play it and when we don't play it. Okay? So now we can actually click to play. So that'll be nice. So the first thing we have to introduce, so just bear with me, there's a few steps to this process. The first thing we have to introduce is this thing, an envelope. And we're going to make a variable called env. And we're going to make an envelope because that's actually what an envelope object is, because that's actually going to be the thing that turns on and off our sound. Okay. And then we're going to define that variable env. And we're going to use this UGen called the envelope generator, envgen, omgen.ar. Okay. Oh, and then, semicolon ends the line. I forgot to mention that, but it's pretty obvious. You see that? So envelope generator.ar just generates an envelope. And basically, we're concerned with two main arguments here. If you put a comma in there, you'll see, what it says. The actual envelope, the envelope shape. And then this one called gate, which is basically something that opens or closes the envelope. So if you get a 0, it closes the envelope. If you get a 1, it opens the envelope. Okay, so those are the two things we're concerned with. But let's attend to actually defining the envelope. So now we're going to use another object that's going to give us an envelope shape, and that's this envelope generator is going to use this shape to do. So I'm going to use this one called, and so if I do env, it's just a function. It's a set of functions in SuperCollider that allows us to define the envelope shape, and we're going to use just a classic shape. Called, there's the classic shape called ADSR, or attack decay, sustain, release. But in this case, we're going to even simplify it further. We're going to use ASR.ASR, and that's just attack, sustain, and release. Okay. And now we're going to give those two brackets because the envelope shape itself has a bunch of arguments. So if you put a comma in there, you'll see what they are. And they're attack time, sustain level, release time, and curve. Now I'm just going to keep this nice and simple. You can make variables for each of these things, but I'm just going to keep it nice and simple and have an attack. And I'm going to make these all arguments so that we can change them if we want on the fly. So I'm going to make an argument called ATK, say. And of course, I can name them whatever I want. You can name them whatever you want, just as long as it's consistent. And then I'm going to have, I'm going to skip the sustain level because I'm just going to always have that at 1. And then I'm going to have a release. Now, if I'm skipping an argument, now the way SuperCollider works is it just looks for things in order. So now whatever I put here, it's just going to assume it's sustain level. So if I put a word called REL there, it's not going to be the release, it's going to be the sustain level. Now, if I want to skip to release time, I just have to basically type in the argument and a colon, and you'll see. So if I do RELEASE time, like that, and then a colon, it skips sustain level, and this becomes release time. All right, so I'm going to go ahead and just put attack for attack time, and then for the release time, I'm going to use this REL. We'll just keep the curve, we'll keep the sustain level, just make this nice and simple. All right. I'm going to get rid of this comma so that doesn't confuse you for now. So that's going to be the envelope shape. It's going to have an attack of ATK and a release of REL. Now, we're going to have to add those to our arguments. So comma, ATK, and let's just have a real short one for a default. So 0.001, 1 millisecond, a very, very short attack. So kind of percussive. And then an REL, say, default of 0.1 or something like that. So 100 milliseconds or a tenth of a second. All right. So, great. So then the last thing we need here is this gate. Okay. So basically this envelope is generating this ASR shape. All right. And then it's going to, then we have a gate that opens and closes this envelope. All right. So attacks it or releases it. And I can just show you one little trick here. And you can look at the envelopes by using this little plot function. So if I do env.asr, and of course I can't use the words attack and release because these are variables that are defined within my synth.def. But if I want to go ahead and assign a number for attack, let's say 0.01 like I did, and then we're going to have a release time of say 0.1 if I want to do that. And if I do dot plot like that, it'll plot my envelope. So it looks like this. So it's going to take 0.1. Oh, actually, this is 0.01, right, in my actual default here, right? And then I can plot that. I can look at that. So real sharp attack and then 0.1 second decay. Now, if you want to look at different shapes, if you want to look at, say, a really slow attack, say 0.2, and a release time that's quite quick, 0.1, something like that, and then plot it again, it looks sort of like this, and then it cuts. So that's a little trick there. You can look at your envelopes, the shapes. Okay. Now back to the drawing board here. What we need to do then is we need to assign a gate. Okay, and this is where this mouse button kind of thing comes in, to where you can actually trigger the envelope using your mouse button. And we use a UGen called mouse button. And this, again, is control rate, this KR, because it's not making sound. It's just controlling the sound-making parts, right? It's going to control this envelope. So the envelope is audio rate, but the mouse button is control rate.kr, okay? And basically, min val, max val, that's exactly what we want, because a 0, that when I release the mouse, it's going to be 0 and close the gate, and a max val 1 is going to open the gate. Now, the only thing we do have to pay attention to, and this is a little bit persnickety, I guess, or fiddly, but is this lag time. So basically, these control rate objects allow you to sort of have what I would call like a filter, or have a little sort of a little catch-up, little ramp up time, I guess is what you call it. So it would take 0.2 seconds or 200 or 0.2 of a second, 200 milliseconds to go from 0 to 1. So even though I push it, it's going to wait. It's going to go from 0. Say I'm at 0 when it's let go. If I push it, it's going to be 1, but it's going to take 0.2 seconds to get to that 1. Okay, so we don't want it. We want this to be instantaneous. So we do want to define the lag. So that's the only argument. 0 and 1 is perfect because that's going to open and close your gate. But we're going to use this lag and then colon that nomenclature. And we're just going to make the lag 0 because we don't want any lag time. We just want it to instantly be 0 or 1. We want it to respond directly to our mouse. Okay, so we do have to put in that in there because the lag time there is by default this 0.2, which is very long, especially in terms of music. So that's like if you were at 60 beats a minute, that's like a kind of almost a 16th note, a short 16th note, which is a pretty long time, right? You don't want to wait that long for your sound to kick in. So we're going to change that lag to 0. So that's the one sort of kind of fiddly thing we need to do. So there you go. We have our envelope now. It's being generated by this envelope generator. It's going to use this ASR shape with two arguments defined as attack and REL, ATK REL. And then we're going to use our mouse button to open and close that envelope. So the very, very last thing we need to do is we need to employ the envelope. And how you do that is you just multiply. So our synth will be times the envelope. So we have the sine wave going woo, and it's going to be multiplying this envelope. And the envelope, when it's on, it's going to go to 1. So it'll be something times 1, or it'll be itself. And when the envelope goes to 0, it'll be 0. So synth times 0 will be 0. So nothing will come out. All right. So the sine wave will either be itself or at 1 when the envelope is all the way open, or it'll be at 0. And then it has these ramp ups, right? So if we want to have a long attack or whatever, it'll be wherever it is and that attack time. So completely duplicate the envelope. So that's a very simple multiplication there. So if we go ahead and evaluate that, and then we start it, no sound. Well, that's because it's now my mouse button is controlling the sound. So if I click my mouse button, it comes out. If I release it, it lets go. So now I can, and then let's do change our range there. So if I want to do my rendition a little bit better. Oh, very out of tune, isn't it? Oh, it's horrendous. Oh, it's terrible. Okay. All right. Well, anyways, you get the point now. We can actually articulate. We can create like sort of distinct notes. So that's pretty good. Our mouse theremin is practically there. Now we can hit, a button to attack a note, and we have a pitch controlled, and we can define what pitches are going to be. Now, the very last thing we're going to do to complete our mouse theremin, to complete our basic mouse theremin, then maybe I'll show you some alterations. The very last thing we're going to do there is to change the volume. Okay, and we're going to use our mouse Y up and down there to change our volume, so it becomes much more like a theremin. So if we do that, we can just use a simple amp, and we can do something like this. We can do a variable called amp. So let me copy this. So we have various versions. Okay, and this is now adding amplitude. So we'll just make a variable called amp. And then we'll define this amp as our mouse Y. So we'll say amp equals, just like we did with the mouse X here, we'll do mouse Y, y.kr. Now, by default, the min values is 0 and 1, and that's perfect because our amplitude, we want to keep it in that range, 0 to 1. Above 1, it'd be clipping. You can't go under 0, really. Okay? And the only thing we have to address really is this lag time. We don't want, that's really much too long of a lag. And in fact, this one too, we wanted to address that lag. So I forgot about that. Let's address this lag. And we're just going to call lag, and we're going to go 0, okay? Because we don't really need that lag. Or with pitch, sometimes it's good to have a wee bit of a lag. So let's do 0. So it's not choppy. Maybe 0.10 milliseconds, or maybe 30 milliseconds, 0.03, okay? And then the mouse Y, we don't really need any lag there. We just want to change volume right away. So Min val, max val, again, I said it's perfect, so we're just going to use skip over those arguments and use this nomenclature lag, the colon, and we're just going to make that 0. Okay, we do have to change that. So now the amplitude, depending on where my mouse Y is going to be 1 or 0. And actually, it's reversed, so maybe we do have to define these. It's actually 0 up here, and it's 1 down here. So let's reverse those. So we do have to be explicit. So we'll just say the low value is going to be 1, and it will automatically, reverse things. Even though it says min val, it'll go from 1 to 0. It's fine, and we'll do max val 0. Okay, because in fact this is 0y, and this is, maximum y, right? Okay, that's 0y, that's maximum y. So we want to go from 1 to 0, and it's smart enough to know that even though that's bigger than that, it'll just go in the other direction. Okay, so I think that's pretty much it. Oh, we do have to multiply now by the amplitude. Just like the envelope, we have to multiply that by the amp so we can control our amp. So let's do that. Let's send that, and let's get an instance, and then so we can go a little quieter. Now, if I wanted to be really fancy, I can do some kind of more exponential thing. I'll just throw it in here for once. You don't need to worry about this, but if this interests you, you can do this as well. We can just sort of do this mapping. We're going to go from lin to exp, and we're going to go from 1.0 to 0.0, and again just to 1.0 to 0.0, and all that is just sort of curves it a little bit. It curves the so that it gets louder a little quicker. So we send that. I hope this works. All right, okay. Well, that's not working that great. So maybe we'll just forget about that. There's a number of other functions you can use. Lin exp, exp lin, etc., etc. There's you can use decibels. It'll do conversions. But actually, that was probably unwise to get into that right now. So I'm just going to erase that bit. And that's pretty much us there. We have a basic working mouse theremin that has volume control, has pitch control, and then also uses the mouse button to attack. And you can change the attack release time on the fly if you want, and also the pitch range if you want, all right, using the set command. So that's pretty good. So that's pretty much the basic. Now, you can stop now and just go ahead and play with this for a while. You have everything you need for yourself to make some pretty interesting music. But I'm going to continue this on, and if you want to continue, great. And I'm just going to show you some variations to make the sounds kind of different, something a little bit better than just the sine oscillator. Okay, so let's just take our working mouse theremin. Everything's working great. We're just going to sort of jazz up the sounds a little bit. And the first thing I want to do is introduce another type of waveform. So the sine wave is kind of a very pure tone. It's almost like this sort of type of tone, almost like a flute, or if without any vibrato, or if you sort of blow over a bottle, and I'm sure we've all done that. You blow over a bottle and you create this very sort of pure tone. Now, you can use other waveforms that aren't so pure, like a sawtooth wave, or triangle wave, or square wave, the pulse wave in this case. So we're going to try maybe a sawtooth wave, okay? So if I just change that, instead of sine os, I can use this one called saw.ar, okay? And that's all I have to do. So if I do that, you'll notice right away the change in timbre. Okay, so it doesn't seem to like my mouse because I think there's a phase thing here. So the only reason it's doing that, not changing. Oh, well, no, I'm sorry. I was okay because it's on the x-axis. I forgot y-axis is my volume. So you notice it's a very different timbre, right? Okay, well, I'm going to give us the option of using a couple different waveforms and being able to sort of mix them together, all right? So if we want to maybe create a couple different variables, we'll call it synth. We'll call it maybe, instead of synth, I'm going to call this, well, we'll keep synth. And no, you know what we'll do? We'll call them os, okay? So we'll keep synth, but we're going to add some oscillators. So we'll say OSC1, and then OSC2, and then OSC3. Okay, well, you have 3 different waveforms. Okay, and let's stick them right in here. So instead of synth, I'm just going to rename this OSC1. Okay, and then I'll send this back to the sine. We'll just make our sine our original SINOSC. OSC1 will be original sine os. Okay, and then we'll make this one OSC2. We'll just copy that line, and I'll make this saw. Okay, and then I'll copy that line again, and then I'll make an OSC3. So now I have 3 different waveforms to choose from, and I'll make this one a pulse or square wave. The square wave is called pulse here. All right, and I just want to make sure our arguments, the first argument here is frequency, so I just replace that comma. Oh, sorry, here, put a comma in here. Right, okay, so the frequency is still good. All right, so now, so great, we have 3 waveforms. Now, in order to use all 3, we're going to mix them together. We're going to use this UGen called mix. So now our synth will be defined as this mix.ar, okay? And again, those brackets there. Now, what mix needs is an array, and I won't go into what that is right now, but basically, it needs these square brackets, okay? So even though it has these sort of parentheses, these brackets out here, it needs these square brackets and need an array of different things. And what the different things are going to be OSC1, our sine wave, OSC2, our saw wave, and OSC3, our pulse or square wave. Okay, so now these are all mixed up and then sent out. So let's see how that sounds, all 3 waves. And they have the same parameters in here, the mouse X, so they're all going to be at the same frequency. Okay, so let's do that. Okay. Kind of sounds like the saw. The saw kind of dominates that. Okay. So let's kill that. And let's see if we can do a true mix where we can sort of independently change the levels. And so we're going to make these arguments here, and we're just going to give amplitudes to each of those. Okay, so we can do os 1 amp, and then we'll just make them all equal to 1. And OSC 2 amp, that's a default 1. And then OSC 3 amp, and we'll make that default 1. Now, if you run out of room, SuperCollider doesn't usually care about hard returns. It still sees this as, just still read that part of that line. So I'll just sort of hard return it there to give myself a little room. All right. And in order to employ these arguments, we're going to have to multiply here. So we'll do OSC 1 amp, and then we'll multiply that by OSC 2 amp. And then, oops, I forgot to multiply. So the actual waveform, the oscillator 2, is going to be either multiplying by, 0 if you don't want any of it, or 1 if you want, full range. And then this is going to be multiplied that OSC3 AMP. Now, just a general rule of thumb, you want the total sort of volume level to all add up to 1. So if I'm actually, so maybe I shouldn't make it a 1 default, but 0.33, maybe something like that. Okay. We want, if we're going to use all 3, we want them to add up to 1, otherwise it will clip. All right. So this is the first oscillator, sine os, times this amplitude, os2, os2 amp, os3, os3 amp. Okay, so now we have independent level controls. So if we send that, and then, oops, and then send an instance here, okay, we have all 3 at, 1/3 volume, adding up to 1. But we can use a set command. I'll just copy this one in case we want to keep that pitch low, pitch high. And then we can change the mix. So if I want to say get rid of if I want maybe just sine oscillator, we'll say OSC 2 amp, or the amplitude of my sawtooth wave to be 0. Change that to 0. And then OSC 3 amp, which is the pulse wave, to be 0. Change that to a 3. If we do that, then see it's back to just a sine. And then we can turn that up too. We can say OSC 1 amp to 1. We just turn that up so it's not too faint. That's just sine. Now, of course, we can do a different mix there. If you want to be just saw, we'll take that one to 0, which is our sine wave. We'll take that one to 1, which is our saw wave. And then you want to 0, which is our pulse wave. So if I execute that, it's just saw. And of course, if we want to just do our pulse wave, we'll just make that 0. And then OS3 will make 1. And then that's my square wave. Of course, we can make square waves sometimes are nice bass things. So we can make maybe this like, I don't know, like 45 to maybe 50, 55, something like that. Or maybe even lower. Let's go 35. Oh, it's terrible. Okay, so yeah, I have bad intonation on the mouse theremin. I'm going to have to work on that. Okay, so in any case, you see how you can do the different mixes. Of course, you can do different, a little bit of each. So again, if I want to say half and half, say pulse wave, and half, let's see, 0.5 and half saw wave, 0.5, we can do a mix there. And that's pulse. That's kind of nice sounding. Little crunch of the saw. Okay, so that's one way to jazz up your mouse theremin, is to have sort of a mix of different waveforms and create nice things. Now, another interesting way would be to just have independent pitch control as well. Okay, so this is going to be a couple steps, and just bear with me. Let me shut this off so I'm not always making sounds every time I click. And so just bear with me. Now we're going to copy this. So see now, if you followed along all the way from the beginning, I know this has been a while, but follow on the beginning, you see we started quite simply, and we just sort of built it. And now it's pretty complex, But if you sort of followed along, I'm sure you understand what all these steps are. Even though it looks like a lot of code, really isn't that bad. And if we just do it incrementally, step by step, it becomes quite manageable. So let's now, what I'm saying is, not only would it be nice to be able to mix our different waveforms and their volumes, but it would be nice also to have independent pitch control. Okay, so like I said, we can have, for example, a thing people might often do is to have one waveform at a normal, at what pitch you want it to be, and then have another waveform be an octave lower, so you have sort of a foundational support, sort of a bassy support for it. Or sometimes you can detune two waves, and you get a really nice kind of crunchy pulse kind of thing, or you get some sort of roughness. And I'll show you all those when we get a chance. And of course, this mix thing is not limited to just, so I have 3 waveforms, but you can have as many as you want, depending on how powerful your computer is. But you can do OS 1, 2, 3, 4, 5, 6, 20, 29, 30, whatever, and just continue. It's a little bit of typing, but just continue putting these into the mix, just comma OSC4, comma OSC5, etc., and then they're independent apps. So you can mix a whole bunch of waveforms and have little recipes, by these little set commands. Okay. So if you want independent pitch control, what we'll do is we'll have sort of a general pitch, and then we'll add something to each one. Okay. So bear with me now. What we're going to do is we're going to pop this mouse X thing out and make it a variable. So we're going to call this variable pitch. Okay, I'm going to call it pitch. All right, and we're just going to pop that mouse X out and make it so this independent thing that we can pop back in as pitch. So we're just going to grab that whole thing, I'm just going to go X and our Apple X or cut, paste that up there. So now pitch is this mouse X, pitch low, pitch high, lag 0.03, and it's going to convert it to cycles per second. Okay, and actually, I take that back. I don't want to convert this to cycles per second just yet. I'll do that the very last minute. So I'm going to get rid of that. Okay, so now it's just going to be somewhere between our pitch low and pitch high. In this case, the default 48 and 72. Okay, and then I'm going to add something to it. So I'll say pitch, which is this whole bit. You know, it's the same thing. It's exactly what's still in our other ones, except without the MIDI CPS now. And I'm going to add to that pitch plus os 1 tune, just a tuner. So now I can tune that independently and yet still control its overall pitch with my mouse X. So I'm changing the pitch, but then I'm maybe adding something. Say like I want it to be the same pitch, but 1 octave lower. So I use this OSC 1 tune. So now we'll need another line. I'm just going to make another line here. I'll put a comma because that means I'm going to wait for my next argument. And I'll make another line. And basically, just like I did with all the amps, I'm going to create 3 arguments that are the tuners. So I'm going to go OSC 1 tune. And let's just equal to 0. And then OSC 2 tune. And equal to 0 again. OSC 3 tune. And then equal to 0. All right. And so basically this same bit, except now what I have to do is after I add the tuning bit to it, I then have to finally convert the whole thing to MIDI to the cycles per second or hertz. So I have to do .MIDICPS, okay? And in these brackets here, because that just means that it's going to add first and then convert. Otherwise, it would just convert this and then add to the raw pitch there. So if the tune was 0, you'd get, 72 or whatever. If the tune was 12, you get 12 plus whatever. But this way, you add first and then you convert. Okay? So basically, I'm just going to take this little bit and copy that. Control C, Command C, and then just replace that all in here for all 3 of these. And I'm just going to change that to OSC 2 tune and OSC 3 tune. Okay? So there you go. So now we have independent tuning. We have independent amplitude as well. So we can do a mix of different things. So if I do that and just evaluate that and start it again, it'll just be my typical all 3 playing the same pitch. But let's lower the pulse wave, say 2 octaves. So we can say minus 24. So if we do, and we'll just do an A.set. And remember, those goes in the brackets. The first thing that comes is the argument name, which in this case is OSC. It's the pulse wave, which is the OSC 3. OSC 3 tune. And we're going to put that down 2 octaves, which might be really low, but we'll give it a try. Negative 24, okay? So it's going to plus negative 24 or minus 24. So we do that. Then now, that's kind of cool. We have that 2 up high, and then this low kind of basic thing. Now let's create some roughness with our sine tone. So we'll just detune it slightly. We'll say our sine tone is OSC 1, oscillator 1, OSC 1, and tune, and we'll just detune it slightly. We'll just tune it down, maybe a quarter tone or something like that. So minus 0.25, something like that. Let's see how that sounds. It'll just give us a little roughness. See, there you go. Pretty ominous, pretty sci-fi sounding. Yeah, all right. So that's the horror movie soundtrack right there. So already see with just a few of these steps, we can create lots of different types of sounds, very interesting types of things. And like I said, I've given you a choice of these 3 oscillators. I mean, you can double them up. You can do 1, 2, 3, 4, 5, 6, or like 1A, 1B, and have like 2 sines and 2 saws and 2 squares. There's also a triangle waveform that you might want to give it a try. And if you look at the pulse wave, I'm just going to sort of throw these out there for you to explore. I'm going to stop this bit here. The pulse wave, if you see, if you put a comma, you can see what other arguments. You have this width function, which is kind of interesting. If you mess with the pulse width, it changes the sound quite a bit, and you can sort of oscillate that as well. All right. All right. Now, great. So that really does expand our sonic possibilities just by mixing these waveforms, by giving them independent tuning and independent amplitude. So by messing around with those, you can get quite a long ways to creating some really, really interesting sounds. Now, I'm just going to show you one last thing. One last thing that has two parts to it. And I'm going to show you some filtering if we want. So let's look at some filtering right now. So if I simply filter this synth, okay, I'm going to eat this synth. This method, which I call like a recursive method. But basically, you can in programming, computer's going to execute everything in order. So if I do say synth equals this mixed, it'll be equal to that mix. But then I can say synth is equal to something else and use itself, in the mix. So now this synth is this mixed bit, but what we're going to do is we're going to do this resonant low pass filter. We're going to filter that synth. So now synth is going to be equal to resonant low pass filter.ar, and its source of this filter is going to be synth, which is the original synth, this mixed up bit. Okay. And we'll just keep the frequency at the default right now, but we'll put in, let's put in an argument there. We'll call it freq for filter frequency. Okay. And basically this is just going to be using a low pass filter to filter our sound and give it a little bit more color. So we have to create an argument here. Well, we've created these 3 lines of arguments. We might as well just add that to the bottom line, freq. And let's make that equal to, say, 400 is fine for a default. Okay. And I'll just give you a sense of how that sounds. If I send that and start an instance there, a equals synth. Okay, it's much duller, you see. And it almost sounds more sinusoidal because a lot of what gives a sawtooth wave and a pulse wave or square wave, its edginess is up high. It's higher frequencies. Now we filtered all the frequencies. A low pass filter basically passes on the low end. So it filters all frequencies above 400 out. So if we want to change that a little bit, so it's darker. So if we do a.set and we do freq, and they can make it even lower, pretty much get rid of everything except the sine tone, and even the sine tone barely speaks. Well, if we do this, if we change these tunings, we're going to get some of the pulse wave shine through. Okay, or if we do it to 1000, changes, but still quite dull, and that can be kind of nice too. And of course, if we want to go a little higher than that, say 10,000, that's even brighter. So the higher you go, the brighter it will be. Okay, and so the one thing I actually do want to show you here is instead of actually doing this filter frequency, we're going to put that onto a what I call a low frequency, what we would call a low frequency oscillator. But all that's to mean is it's kind of like a constantly moving, so something that sweeps this frequency constantly. Okay, and you can use these oscillators also as control signals. So I'm going to put a sine wave here. Let me get rid of that. I'm going to put a sine wave here, sine os. And this time I can use a control rate because it's just using to control the frequency, KR, okay? And then the frequency, and then the 2 brackets to just, that's the scope of the sine oscillator. Now the frequency of the sine oscillator, in this case, it was the pitch, right? If I put a frequency in here, it's the actual sounding pitch because it's an audio rate. Here, the frequency is the sort of rate of sweep, right? It's going to sweep through a range of frequencies. So it's a bit to get your head around, but I'm sure you can. You're going to sweep a range of frequencies, except it's going to do it at a certain rate. So if it's, and the frequency is how many times a second. So if I put a 1 there, it's going to go womp, womp, womp every second. If I put a 10 there, it's going to go womp, 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 womp once every 10 times a second. So it's how many times a second, okay? So we'll put that as a rate, okay, because that's actually what it is. It's the rate of sweep, okay? And then the other thing we have to do is we have to put a range of filter the frequency for it to sweep. So these are two different things. So this frequency is the rate of sweeping. This, what I'm going to do now, is actually the range of frequencies which this oscillator is going to sweep. So I'm going to use this this little function called .range, okay, and that has its own little parentheses, its own set of arguments, and it's the same as this, same as the things we've done before, like the mouse X and stuff. It's a low and a high, okay. So I'm going to do, I can just hard code it. I can say I want it to sweep from 100 hertz to say 10,000, and we'll see how that goes. Now we have to pop in our rate here. So we've gotten rid of this filter frequency. That was more of a demonstration. I probably should have started this whole thing over again, but we'll just eat that one and we'll call it rate. And we'll just say we're going to do it 1 time a second, okay? Rate 1. All right, now if I go ahead and evaluate this and send that, hopefully we can hear what that sounds like. So you hear it's sweeping at a rate of 1 time a second from 100 to 1,000, 10,000 hertz. So that's that pulsy thing, that kind of wobble sound. Okay. Now the other thing we can do, of course, is instead of just making this hard coded, we can make f-freq low and f-freq high. Make them arguments. And then here, instead of right, we're just going to add those arguments. So we'll do, and in fact, let's make another line just for clarity's sake, and we'll have a rate, and then we'll have f-freq low and f-freq high. And we'll make this say equal to, say, 50, why don't we? And then f-freq high, and say equal to, again, maybe 15,000, something like that, okay? So, and then we can change that now on the fly if we want to. So now see it's really bulkier code, not bulky, but it's kind of longish and looks like it's super complicated. But if, again, step by step, it's pretty simple. It's pretty clear. So we'll do that. We'll send that to go. So one thing we can do is change the rate, you know, so we can do a.set, oops, the rate, and we can make it much faster, say 10 times a second. So that's it's a laser gun range. Let's see what happens when we change our tuning there. And also, if you want to change your, you know, tuning, you can sort of keep it in the dull end. We can do f-freq low. We don't have to change low, but you know we can keep it 50, but we'll make it maybe 40 then. And then f-freq high, we'll make, say, 500. Okay, make it much lower so it'll be kind of on the dull end. So that really sounds sort of 50 sci-fi. So that's kind of interesting. So maybe we can make it slightly higher, maybe 1,000. And we can take the rate down. I mean, we can really slow rate if you want, like a really 0.5, so once every 2 seconds. That's kind of interesting. Maybe we can make it less dull. Maybe sweep from, say, 200, oops, to, say, maybe 5,000. Now, if you get this rate really crazy, if you go nuts, it starts doing some kind of weird things, and we would call that frequency modulation, which we won't get into right now, but that has a really interesting technique. But let's say we make it like crazy, like 100 or something like that, then you'll start hearing some weird things happen. But interesting. So you can play around with that. You know, somewhere in between, say like 25 might be interesting. So it becomes more of a like a rough, grindy kind of sound. All right. All right. Well, there you go. I think that pretty much does it for our mouse theremin. And if you've been with me for the whole ride, you can see we just built it up from essentially nothing and sort of did it step by step. And at some point here somewhere, we have our basic mouse theremin that's good to go, and you could have stopped there. And here, well, somewhere, I think this was our basic one, somewhere over there. And then here, we sort of added additional waveforms to make it interesting. And then we added ways of changing independently pitch and volume. And then we added this filter, and then we added to the filter a low frequency oscillator. So really you have quite a powerful tool right there, just in these few lines of code. So I say it looks complicated and it looks like a lot, but in fact, if you count on, what is that, 55 to 70, it's what, 25 or what is that? Yeah, 25 or less than, it's like 15 lines of code or something like that, right? 50, 60, 70, yeah. 15 lines of code, not even. These don't really count, right? This one and this one. 15 lines of text will give you this very powerful synthesizer, really, that can change all kinds of different. You play it with your mouse, and you can change all kinds of different timbres and all kinds of different parameters. So really, once you have this going, your work is really only half done, really, isn't it? You have to start making all these settings and finding sounds you like, finding a good mix. But you know, it's kind of like a virtual instrument you might have seen in some of your work, say in some audio programs and stuff. That's like a virtual synthesizer. You can change now all these things and create your own patches. So this is sort of the patching business down here, is creating all the settings that sound really good. If you like sort of a detuning thing, well, let's see if we make that slightly more. It gets really, and then maybe this rate much slower. Or, you know, the other thing you can do really is to, if you want to just have no sweep filter, you just change the rate to 0, and you change your frequency low rate, filter frequency to you know, 20,000 and 20,000. So it'll just be at the highest, the top end of human hearing. So that just gets rid of the filter altogether. And then, you know, we can change the amplitude. So if we want, this is OS3, OS1. Let's make the sawtooth wave a lot louder. So that's OSC2 amp. Let's make that about 50% of it. And then let's make the OSC3 amp, which is, say, at 25, well, let's say 0.30%, and that leaves another 20% here just to give the roughness for the sine wave. So we do that. Did we already tune it? We did tune it, huh? So actually, let's reverse that. Let's make this 0.3 and this a little louder, 0.5. And then let's we can make this a full step, maybe a full half step. That's kind of interesting sounding. So I can pop my filter back in. Maybe I'll make it slightly duller. Let's do it at a rate of 0. Or a really slow rate. Let's do it 0.1. And let's sweep from, say, about 200 to about, say, 7,000. So it's very atmospheric. Maybe make that slightly quicker. Okay, well, there you go. That's an example of some of these things that you can do. And you just have all your settings there, and then you have them good to go. Now, actually, I would be negligent if I didn't show you just one thing. And if you really want to sort of to have a preset from the beginning, you can start your synth instead of just saying a synth equals empty and then using the defaults and then setting them. You can actually start a synth with arguments, and that you do with the square bracket notation. If you put a comma in here and a pair of square brackets there, then within those square brackets, you can put all the settings that you thought worked really good. So I'm just going to copy a bunch of these over that I thought worked really well, all within these square brackets. I'm going to go my little mix there and make sure that there's enough commas and such. And again, it doesn't really care about, SuperCollider doesn't really care about hard returns, so we can just tidy it up there if we want. We can even do something like that so we can see everything. And then, what was it? This tuning one. Right. And I think that was about it. So now, if I do this, if I start this one, if I just kill everything, and if I just start this one, it'll start it like a preset. So like a patch with your synth. So if you think of this definition as your synth, and then this is sort of your preset or your setting. So if I start that, it'll start right into the one I made that I liked. All right, well, I really need practice, so I'm going to go do that and leave this with you. We better end that there, but hope you enjoyed that MouseTheremin tutorial.